Dear students, I welcome you for the today's lecture related to the instrumentation diagram for feedback control system and feed forward feedback control system. That is a combination of feedback and feed forward control systems. So we have to first revise a little bit about what the feedback controller is. The control variable C, that is what we have used the notation control variable, that is the measured and is feedback to comparator and compares with the set point to generate an error. The generated error that is to be minimized by the controller action. So this is our general block diagram related to the process, controller, control valve and a feedback system. So this is the set point R. Then I am going to measure the either temperature, concentration or pressure. So that is to be measured and its feedback that is to be given to the comparator. This comparator, it compares the set point with the measured value B and that generates a error E. So we are having the R, the set point or the desired value, then C, the controlled variable, then M, manipulated variable, U, that is the disturbance or the load variable, then E is the error generated, which is R minus P, that is nothing but P is nothing but the measured value of temperature indicated by a sensor. So all these things, now we are writing it into a system for which we are trying to maintain the temperature in a reaction vessel by using the steam through the coils. So I am going to measure the temperature and it is going to give the feedback to a controller. So this is the measured value which is being taken care by the controller. To this controller comparator, the set point that is also provided, controller takes an action and then it goes to a steam input. That means controlling of the steam input, and accordingly it adjusts its position, control valve that will adjust its position and the amount of the steam going into the system that will be regulated. Then there is a second factor which is the inlet temperature that can vary. There can be flow rate also that can be varied, but there are certain systems where both the things they can vary, the temperature, inlet temperature as well as the inlet flow rate. Or there are certain systems where the inlet temperature can only vary or where the inlet flow rate can vary. Both the things can be there. Or there are systems where neither inlet temperature nor the flow rate that is going to vary. So depending on this, our feed forward systems they are being developed. So use of this load variable is to help for the development of a block diagram for the feed forward systems. Now in general, our system that is related to the measurement of the temperature, where the thermometer or thermocouple that is used, it is transducer is connected to that. That means it is converted into the electrical signal. Then it goes to a comparator and then to a feedback controller. This is what we have discussed in our block diagram also till now. The measured value is measured by the temperature that is measured by a thermometer or thermocouple, and its actual value that is same as a B. So this measured value, it also, in which form, is it mechanical or strain gauge, or if it is electrical, depending on that, the transducer that will be there. Transducer converts the signal into the electrical signal, whatever the signal it receives. The thermometer, mercury thermometer doesn't have a electrical signal, so it has to be converted into the electrical signal, either in terms of the voltages or in terms of the current, 0 to 5 volts or 4 to 20 milliamps, that is to be converted. So for that purpose you require these transducers, and then it goes to a comparator. Then this comparator generates the error, and that error that goes to a controller. Now here this specific term, that is the feedback controller, that has been introduced. Till now we have used only the controller term. We have not specified which type of the controller that is being used. Now today we are discussing specifically the feedback controller, feed forward and feedback controller, combination of that. So whatever the controller action that takes, it goes to a control it goes to a control valve, and this control valve adjusts the steam going into the system. So this is our general feedback temperature control for a stirred tank heater system. So control objective, that is the C, temperature Tc, that is to be controlled. Then the temperature of the mixture in the tank is measured. This is what the temperature of the mixture that the tank is measured, and its value is the P. Then the electro pneumatic transducer is used. The electro pneumatic transducer is used to convert this electric analog signal into the pneumatic signal. Then that comparator compares the measured value with the desired value or the set point. Here the measured value B and the set point value, that is to be compared by this comparator, and the error that is generated. So error that is generated. Then this feedback controller minimizes the generated error. What the functioning of this feedback controller? We are specifically talking here related to the feedback controller. So that is the feedback controller that minimizes the generated error, and it develops a output which is going to a final control element or a control form, and that is called the manipulated variable. So this manipulated variable M, that goes to a control valve, and this control valve adjusts. For the control valve you require the pneumatic signal. In general case there are electrically operated control valve also, but mostly it is pneumatically operated control valves. So this pneumatically operated control valve receives the signal in terms of a pressure, and the actuator adjusts its position, the stem position that will be adjusted depending on the applied pressure. So position of the plug of a control valve regulates the flow of the steam. So this is a in general standard way to define the feedback temperature control of a stir tank heater, you can say. Then I'm talking if the system that is changed, that is a heater that can be provided instead of putting a coil here, instead of putting these coils, they have been removed and a jacket that has been provided. Then there can be a chemical reaction that can take place. Then there can be a simple heat exchanger that can be there. So this is to be applied to the different systems now. So this is the feedback control of a heat exchanger. In general, feedback when we say, that is related to the measurement with the outlet process stream. Feedback that specifically talks related to the measurement of the outlet stream. And that is why every time we are going to measure the whatever the entity we want to control, in case of a heat exchanger, the temperature control. In case of a distillation column, it can be either temperature, pressure, or composition control depending on the process requirement. Then the heat exchanger. In a heat exchanger, the inlet temperature of the fluid that is entering, the process fluid that is entering at a temperature of Ti, and it is leaving at a temperature To. And this outlet temperature controlling is my motto, is my purpose. For that, I am going to measure this outlet temperature with the help of a thermocouple. Then the transducer that will be required. Then that goes to a B signal, goes to the comparator, where R set point minus the B that will generate an error, and which is going to a feedback controller, specifically a feedback controller. This feedback controller takes the action and then it goes to a control valve. Control valve regulates the supply of a steam or the cooling water. If you want to reduce the temperature, when you are using the steam, then you are going to increase the temperature. That means T1 is greater than the T0. Then there is a system where the jacketed continuous stir tank reactor is there with the exothermic reaction in this case. The same previous system, that is the thermocouple, transducer, control, comparator and feedback controller, that will be there. And that is everything is measured with the fluid which is going out. Now whatever the fluid which is there inside the tank, the same fluid that will go out. So I am measuring the temperature in the reaction vessel. So thermocouple that is used, the transducer that is connected, then a comparator that is used, and then there is a feedback controller. The system till now is the same here, but it's a exothermic reaction. So in this exothermic reaction, whatever the heat that is generated, that is to be taken out, and for that purpose we are supplying this cooling water into the jacket, and as a result the cold liquid outlet temperature that is to be measured. So this thermocouple to measure the cold liquid outlet temperature, a transducer, a set point, a comparator and a feedback controller. So there are two feedback controllers that is used in this case when the reaction jacketed continuous stir tank reactor with the exothermic reaction that is there. In case of an exothermic reaction, the two entities measurement of the two temperatures that becomes the more concerned. One is the temperature measurement for your liquid, and this is of concern, which is our desired value. And the second that is also important, that is the cold water outlet temperature. So both these are to be compared, and then the final decision that is to be taken, which is going to a control valve which adjusts the coolant temperature. So this is the feedback control of the jacketed continuous stir tank reactor. So instead of using only one feedback, here in this case I am using the two feedbacks. One is related to the actual temperature of the process fluid, and second is that of the utilities, which is nothing but a coolant used to reduce the temperature inside the jacket. So both entities, both the temperatures are to be measured in this case. Now next is the feedback control of jacketed continuous stir tank reactor for endothermic reaction. So endothermic reaction, not a very huge amount of the heat that is generated. You want to supply the heat in case of endothermic reactions. Because we are using the steam to increase the temperature, in general case, whenever the steam that is used, we are considering only latent heat that is transferred. We are not taking into account the changes in a temperature. Sensible heat that is not taken into account. Only the latent heat that is taken into account. That means whenever the steam that is used, the condensate will be also at a same 100-degree temperature. And that is why we are always knowing the condensate temperature, that is 100 degrees Celsius, but in a liquid form. And that is why we are definite for this outlet temperature of the steam. In the previous case, that is related to the exothermic reaction, we have measured the outlet temperature. However, we are not measuring the outlet temperature of the utility, the steam, in this endothermic reaction, because we are assuming, or it is presumed, that only the latent heat is being transferred. No sensible heat that is being lost or that is being given by the steam to the process fluid. So there is only one loop that will exist, that is only the measurement of temperature with the help of a thermocouple, then the transducer that is to be connected, then a comparator, and that goes to a feedback control system which is going to send the pneumatic or the pressure signal to the control valve to adjust the supply of the steam. So this is the general process. Now coming to a distillation column, the feedback control of a distillation column. So we are trying to maintain the composition in this case of a distillate. Composition of a distillate that is to be maintained. For that purpose, I am going to measure the composition measurement. Then it goes to the transducer, or transducer gives the signal in terms of a electronic or the desired format, and that goes to a comparator where it compares it with this measured value that is compared with the set point, which is going to generate an error. This generated error is sent back to a feedback controller. So this is specifically a feedback controller, and this feedback controller takes an action or on the control valve to adjust the amount of the reflux which is going into the distillation column. Depending on the amount of liquid which is being going back into the distillation column, that is what your L by D ratio. L is the reflux and D is your distillate. So this L by D ratio that is to be adjusted. So this is related to the distillation column. Then also I am having the feedback control of a drum boiler level that is to be maintained. So for that purpose, the level measurement is used. Till now we have talked related to the temperature, then the composition measurement, now the level measurement that is there. Level measurement in a boiler drum. So level measurement that is done, then it goes to a transducer where it is obtained in terms of a electronic signal that compares with the set point and then to the feedback controller. So feedback controller, it takes the action and sends the signal to the control valve. This control valve adjusts the amount of the feed going into the drum. So this is the simple feedback controller. So similarly, the level measurement in a tank, then the bottom of a distillation column, there is also the temperature measurement in the bottom section, then transducer, then feedback controller, and which is going to adjust the amount of the steam going into the reboiler, which maintains the bottom temperature. So all these different measurements. Now in the previous case of a distillation column, the measurement here, the measurement is the product composition. Now here the measurement is the temperature of the bottom material. The next is the feedback control of a jacketed kettle that is being used. So temperature measurement, transducer, comparator, controller, and then to the control valve. Then in case of evaporator, that is the amount of the vapors generated. Then a transducer, then comparator, feedback controller, and again going back to adjust the amount of the steam which is sent into the heat exchanger or the evaporator. Now next is feed forward, feedback temperature control of a stir tank heater. Till now we have discussed related to the feedback only. Now we are using a feed forward and a feed backward loop. That is a combination of the two things, that is the feed forward as well as the feed backward. So in feed backward, we were having only the thermocouple, transducer, comparator, and a feedback controller which is going to maintain the position of a control valve. But in this feedback system, there is another loop. which is the temperature variation for the inlet flow rate. Temperature variation for the inlet flow rate. So there is a need to measure the inlet temperature with the help of a thermocouple. Then it goes to a transducer. Then it goes to a comparator and the feed forward controller. That means here the two things are there, that is one in the inlet process stream temperature, Ti, and the temperature of the mixture, that is in the B value. So these two values, they are to be controlled in this only one value that is to be controlled with the help of a feedback as well as the feed forward control loop. So two loops are used. One is related to the inlet process stream temperature and second is the temperature of the mixture which is going out, and that is of more concern. So now we are comparing here the feedback and the feedback with the feed forward. So feedback that incorporates only thermocouple, transducer, comparator and feedback control. Here the same thing, thermocouple, transducer, comparator and feedback. Now there is the addition of this comparator is there, and this comparator, second comparator, which takes one signal from the measured value and the second signal from the inlet temperature. So this inlet temperature, that is depending on the thermocouple, transducer, the feed forward controller, and that is going into the comparator. This comparator takes the corresponding action and gives the signal to the control valve which adjusts the steam position. So this is what a comparison between a feed forward, feedback and feed forward feedback loops. The next is in the case of a heat exchanger. In case of a heat exchanger, we are having a feedback system, that is the outlet temperature which is measured with the help of a thermocouple, then transducer, then comparator, then feedback controller, and which gives the signal to a control valve. However, in case of a feed forward and feedback controller, the three entities they are of concern. That is the inlet temperature, the inlet flow rate of the process stream, and the outlet temperature of the process stream. In case of a feedback backward, the outlet temperature of this process stream, that is of concern. In a feedback system, the outlet temperature of the process stream, this is what the outlet temperature of the process stream. So this is the feedback loop, that is, you can say. Now in case of a feed forward, there is the inlet temperature as well as the inlet flow rate of the process stream that is to be adjusted. So this inlet temperature as well as the inlet flow rate that is to be adjusted. So two measurements are there, flow meter and the temperature measurements are there. So the transducer that is required, then comparator that is required, and which gives the signal to the feedback controller. So both the measurements are going to give the feedback controller, and this feedback controller then takes the action and gives the signal to the control valve. In addition to that, so two responses, that is one is from the flow rate, second from the thermocouple. So there is a one feedback controller to give one feed forward controller which is measuring the response from the flow meter and from the inlet process stream. इनलेट प्रोसेस स्ट्रीम में दो चेंजेस हो रहे हैं, दैट इज वन इज द फ्लो रेट एंड सेकंड इज द टेम्परेचर. However, the outlet process stream में only the temperature that is sensed. So that is to be compared by a comparator, and this comparator takes the final action which is going for the control valve. The next is a jacketed continuous stir tank reactor for exothermic reaction. Now if you will see in this case, there are four loops which are available. One is the inlet composition, then second is the inlet temperature, inlet composition and inlet temperature. This is my process fluid which is entering into the reaction vessel, the inlet temperature and the inlet composition. So these two process fluid parameters are well versed in this jacketed continuous stir tank reactor system. So inlet temperature and inlet composition is there. And for the outlet, I am going to measure the mixture temperature which is going outside and the outlet temperature of the coolant, because this is a exothermic reaction. We have already seen in case of a feedback controller about this exothermic reaction. There we have taken into account the outlet temperature of the coolant. So outlet temperature of this coolant, that is also measured with the help of thermocouple, transducer, the comparator and the feedback controller, and which is going to give the signal to this comparator. So this comparator becomes the more and more important, where the two feedbacks they are provided. One is from the temperature measurement, mixture temperature is this thing. Then the outlet temperature of the coolant is this thing. So two that has been added, and there is also a third thing that is also coming here in this comparator, and this is from the feed forward controller. This is from the feed forward controller. So feed forward controller, that is concerned with the inlet composition and inlet temperature. So this comparator that receives the three signals, one is from the actual mixture temperature, the second that is from the outlet temperature of the coolant, and the third that is from the inlet composition and the outlet temperature. Now comparing this with the feedback control system only. So in case of a feedback control system, only the two loops, that is your thermocouple transducer and feedback controller, thermocouple transducer and feedback controller, and here the outlet temperature of the coolant, transducer and feedback controller, outlet temperature of the coolant, transducer, comparator and the controller. However, the feed doesn't have any control system. So in this case, the feed that is having the two controlling functions, that is your composition measurement and the temperature thermocouples, or the temperature measurement for the inlet fluid. The next is a feed forward feedback temperature control of jacketed continuous stir tank reactor for endothermic reactions. Now it is the endothermic reaction that is coming into the picture. So endothermic reaction, here we are measuring the inlet composition and the outlet composition. The inlet composition and the outlet inlet composition and the inlet composition and the inlet temperature, they are measured. So inlet composition and inlet temperature, they are measured. that is going to give you the feed forward response. And in case of a feed backward response, it is related to the temperature of the mixture. That is related to the actual temperature of the mixture. This is. So in this case, only the three loops are there. However, in case of a endothermic reaction, there are four loops. Fourth loop is measuring the outlet temperature. This is the steam, and that is why we are considering this as a condensate, and the condensate is having the temperature at 100 degrees Celsius only. Only the heat transfer is by the phase change. Then this is the again comparison, the same thing, the thermocouple measurement of the temperature with the help of thermocouple, transducer, comparator and feedback controller. Then same thing is to be seen, and the signal is going into the control valve. Here also the signal that is going to a comparator and then towards the control valve. Then this is a distillation column in which the control of a distillation column, that is for the feed forward and feedback control system. So in case of a feedback control system, your composition at the distillate. So this distillate, its composition that is measured, transducer is required, then comparator and feedback control system, then that goes to a comparator. So comparator receives the one signal from this feedback loop. However, from the feed forward loop, we are having the inlet temperature, inlet flow rate and inlet composition. So for this feed flow rate, the inlet temperature and inlet composition, they are of concern. So both the measurements are done, that is your flow measurement and the component measurement, which are going to receive the certain set points, and that is going to give it to the feedback controller. So two feedback controllers are there in this case. One is related to the feed forward and one feedback. So this is feed forward controller and this is the feedback controller that is available. So this feed forward controller that receives the signal from the two measurements, and the feedback controller receives the signal from the outlet composition. Then similarly, there can be the feed forward feedback control of a drum boiler. In this case, the steam flow rate, is to be measured, that is going to a transducer and feed forward controller. Then second is the feed water flow rate. This is my feed water flow rate, and the steam flow rate is this thing. This is my outlet steam flow rate. Steam flow rate is the outlet steam flow rate which is to be measured, and the feed water flow rate, that is also there. So two inlet flow rates, and the third one is your level of the feed water in the drum. This level which is to be maintained. So level measurement, transducer, then feedback controller, and which is going to a comparator. So this comparator receives the signal from feedback controller as well as the feed forward controller. So this comparator is of more concern as it is going to receive both the signal, as receive the signals from both the controllers, that is your feedback controller and feed forward controller. Then this is also the liquid level control system in case of your feed forward and feed backward system. Previously, it was only the liquid level transducer and feedback controller. Now the additional loop for the feed forward, in this case, the flow rate measurement that is of concern. Flow rate may vary. So I have already told either the flow rate or the temperature measurement that becomes important and becomes critical in case of your feed forward control systems. Then there is a feed forward and feedback control at the bottom of a distillation column. So this is what the bottom of a distillation column that is available. Here also the composition and the flow rate of the inlet feed that is being used. The feed which is measured with the composition and the flow rate. So they are taken to a feedback controller. This feedback controller that sends the signal to and the composition measurement signal from the feedback controller, it goes to the signal for the comparator, where the comparator receives the temperature signal from the bottom product, and then it is compared, and which controls the steam supply going into the bottom of the heat exchange, bottom of a distillation column. So there are another systems also like this.